get the, especially on this one. Okay, so this is log 2. All right, this is 3x cubed minus log 2z to the 5, because if it's the quotient, right? If it's a fraction, it's a subtraction, right? Okay, this power rule is going to go to the front. But here you also have a multiplication here, 3 times x cubed. So some students did ask me, like, is there a difference between this? And yeah, this is equivalent to this. The 3 is separate from the x cubed. So this is actually log, I know I'm kind of writing a lot more than what you guys. So this is what you have. So I'm taking the 5, right, with the power rule. Here I'm taking the product rule because 3 and x cubed are separate. And now this power rule needs to come to the front. And so this is what you ultimately have. So it was a lot. This one had all 3, power, product, and quotient. Okay. All right, here, this is a 1/2. So log base 4, 12x cubed. And so this one had, some of you did solve it differently. Okay, again, power rule, bring that. Okay, you can, if you're comfortable, you can start separating that with the product rule. And so I would put a big bracket and write 12. And then plus log base 4x cubed, and then of course I have the power rule to bring that forward. So you could have written this, and then I'll write it the other way because some of you guys did have that. Okay, so this was acceptable. Or if say you want to distribute the 1/2 to each, it would be 1/2 log 4 of 12 plus, and then you would take the 1/2, 3/2 log 4 of x. So if you wanted to bracket it or not, it was one or the other. Okay, go to condense. Yeah, okay, so condense the power rule backwards then. Oh, my arrow went too long. Sorry, we'll come back. Is that 3? This 5 is going to go to this 5, and this 2 is going to this 2. You guys were good? You were able to get that, right? Okay, so now it's just a matter of, because you have a subtraction here, right? It's -5, or you could think of it as being with the quotient of fractions. So now you have a fractional argument for this log. Okay, x cubed is on top. This -5, y to the 5th is on the bottom, and z squared is on top. Or if you didn't want that, you can kind of baby step it and write x cubed plus log 4 y to the -5 plus log 4z squared. So then log 4, you have x cubed y to the -5 z squared, but this being negative, a negative, right, exponent, you reciprocal, right, to make it a positive, and so then that's how you can come back here. So you could have done it in 1 or 2 steps tops, but like obviously on this one I kind of did it in 3 steps. Here I did it in 3 steps. It just depends. Are you guys doing little baby steps, or are you kind of just saving time and doing multiple? Okay, keep going. Okay, this is where I told you not to expand, so you guys were great. Power rule, this is a 3rd. Power rule, this is the 5. Power rule, this was a 4, and this is where eventually we'll do Pascal's triangle. You do not have to expand that out. So then it's plus plus, so this is all product rule. So log base 2, 3 cubed times a to the 5th times b minus 5 fourth, and you could have just left it as that. Some of you did make this a 27, but you didn't get, obviously you weren't going to get docked if you didn't do that. Okay, that's it. Yeah. Okay, go to the back side of the front. Are any questions? Remember, the way you get rid of a negative exponent is by the reciprocal property. If it's negative as a denominator, it's positive as a numerator. If it's negative as a numerator, it's positive as a denominator. You just flip the position, and the exponent will switch. Okay, I'm still recording, so let me go to this sheet, and then because the first 8 go fast, okay? All right, oh, you know what? I know for sure I don't have that paper. Yeah, I don't have the paper there. Hold on, because I know you guys had it. So, let's use my phone. Let's use the phone. Images. Images. Do I want to click? Wi-Fi's bad, you guys. Okay, let's take a screenshot. So now let's, wait, what am I doing? Okay, this is, you guys had a worksheet. I'm just using my phone right now because I'm not going to be able to find it this quickly. Okay, y, b, x, and then log b, y, oh wow, b, y equal x, okay? All right, so look, remember, I tell you guys, oh, well, you guys are used to doing it this way. Okay, I tell you guys, circle around, and so some of you guys did that. You guys had little arrows here, which was cute. All right, so this, you could have thrown it in the calculator, but it's just 3. 10 cubed is equal 1,000, right? 4 to the negative 3 gives you 1 over 64. So everybody got this right. You guys know you could just go to your calculator, right? And just substitute it. Okay, here you want to express it in log form. This is your base, this is your exponent, this is your argument. So it's going to be log of base 9, 6,561 to the exponent of 4. Right? Because then think about it. It's your base, 4 is equal to that number. And so look, 9 to the 4th is equal to 6,561. So just kind of do that counterclockwise rotation if you want to check, okay? All right, so then here, log of base 10 of this argument is equal to this exponent of negative 1. And check it, 10 to the negative 1 gives me 1/10. 10 to the negative 1 is 1/10. Okay. Okay, so then here, so now rotate. 3 to the 4th is equal to 81. 10 squared is equal to 100. Yeah? That's why I said the first 8 were really quick and easy, and you guys got them quick. Okay, so then here, 6 squared is equal to what number?
36.
Right, 36. Right? And you guys could write x equal 36. A lot of you wrote that. X cubed is equal to 125. And you guys got 5, right? And then 6 to the negative 2 gives me what number? Throw that in a calculator, but it's just 1 over 36, right? Because it's negative 2. So it's going to be 6 squared over 1. And what's 6 squared? 36. Okay, bottom part, this goes back to your first test. You have to solve using log and exponential rules. You have to show your bases are the same in order for you to go into the equation solving. So this is 3 to the 5x is equal to 3 cubed 2x plus 1, because 3 times 3 times 3 is 27. Now that I have the like bases, 5x is equal to 3, 2x plus 1, negative x. So x is negative 3, right? Take the x over into minus 6, negative 1. Okay, here, you need to get it in 2's. 2 squared, negative x, 2 to the 5th. Is it 2 to the 5th? Here, let me get my calculator. Hold on. 2. You guys, remember I'm still recording. Right? I got 3 more left, yeah?
Yeah.
Okay. All right, here, this one, some of you that solved this, you just did an arithmetic error. You did beautifully. So look, 4x minus 2 equal negative 5x plus 5. And whoever messed it up, that's fine. They're human. How is it that the three of you couldn't figure out that they subtracted wrong? Look, remember, if you make a mistake, it's okay. It's shame on everybody else that didn't pick it up, right? Because, I mean, I make mistakes up here. Look, what's the opposite of negative 5? Positive 5. So this is 9x. Some of you had a 1. Okay, so then minus 2, 5, add 2. Some of you have 3's here. Again, we're gonna make mistakes. We're human. So it was 7/9. If you guys got 1/3 or something with a 3, you just accidentally did arithmetic wrong. And hey, I do it too. Okay, this one here. Okay, in order to, remember, this question, this one, and this one was to show you guys you cannot drop your bases unless you have one term on the left, one on the right. One on the left, one on the right. One on the left, one on the right. Here, you can't do that yet. I have 2 log terms. I need to combine them. But it's a product because it's addition. So log base 5, 6 times 2x squared, log 5, 48. Now I can drop my logs, and that's 12x squared, 48, divide by 12, 4 square root, and you get plus or minus 2. This is going to be a really long video. Okay, last one. You guys can replay it. Okay, so last one. It better not glitch. Oh my god, if this thing glitched right now. Okay, log of 4. And by the way, you guys did this one really, really well. A lot of you were able to get it. Okay, you got this. Do you guys see a log on the right side? No. So you couldn't just make it this. What do you have to do? That rotation, the base to that exponent is equal to that value or that argument. So I had to go 4 squared is equal to that ratio. So 4 squared is equal to this, which gives me 16 is equal to 3x minus 2, 4x plus 1. Okay, now you cross product property. And so now you're going to get a really different, is that 64 or 48? 64? Yeah, 64. 16 times 4, 64. Okay, subtract 3x, 61x. And then subtract 16. Is it showing? Oh, sorry. And so your answer is this. Yeah. All right, we'll go to the front page, but let me, I'll stop the video. Okay, I'm going to stop it because it's probably like